Hey, mathematicians, gear up as today we'll talk about solving word problems that involve adding and subtracting fractions in them. Let's get into it with our I will statements first.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen as I read the first one. I will represent a whole in equal parts. Read that one with me. I will represent a whole in equal parts. Let's look at the second one. I will add or subtract fractions. Read that one with me. I will add or subtract fractions. Nice job, mathematicians. And one more. Listen to me first. I will write the final answer as a statement. Read that one with me. I will write the final answer as a statement. Nice job. Let's get into our warm-up. For our warm-up activity, you'll need your personal whiteboards and a marker. For this activity, we're going to practice and review adding and subtracting fractions. Let's start out with the problem 3/6 plus 1/6 plus 1/6 equals blank. Write this problem on your whiteboards too. When we are adding fractions, we are looking to have the same denominator. Since we have the same denominator here, we're going to keep it the same in our answer. As for our numerator, we're going to just add these numbers like normal. Everybody, what's 3 plus 1? Shout it out. 4. Good. What's 4 plus 1? Everybody shout it out. 5. Nice job. That means our answer for this would be 5/6. Good job, mathematicians. Let's flip it over and try a subtraction problem now. Erase your whiteboards and let's try the subtraction problem. 7/8 minus 2/8 equals blank. Just like when we add fractions, when we're subtracting fractions, we're looking for the same denominator. Since we already have the same denominator here, we can just write it in our answer. We don't have to change anything. We're subtracting now, so we have to look at our top numerators and take one away from the other. What's 7 minus 2? Everybody hold it up on your fingers. You should be holding 5 up on your finger. Let's write 5 into our answer here. Read this fraction with me. 5/8. Nice job, mathematicians. Let's read the whole number sentence. 7/8 minus 2/8 equals 5/8. Good job. I'm going to give us a few other adding and subtracting fraction problems that I want you to try independently or with a neighbor on your whiteboards. Erase your whiteboards and I'll show you those problems now. Here are the following problems I want you to try on your whiteboards. You can split your whiteboard up into 4 separate parts, kind of like I did, but give yourself more space so that you can show your work. For this activity, I want you to add 5/10 plus 2/10 plus 2/10 for the first problem, 2/5 plus 2/5 plus 2/5 for the second problem, 5/6 minus 1/6 minus 2/6 for the third problem, and 1 whole minus 7/10. Solve for the answer of each of these problems and come back when you're ready to see the answer. Pause the video now. The answers for these problems are as followed. 5/10 plus 2/10 plus 2/10 equals 9/10. If you had that for your first answer, give yourself a high five. Let's look at our second one. 2/5 plus 2/5 plus 2/5. We're going to erase For this one, you could have had 6/5, or you could have had 1 1/5. If you have either of those answers on your whiteboard for the second problem, do a little dance. Now let's look at our next one. 5/6 minus 1/6 minus 2/6. The answer to this one is going to be 2/6, or you could have simplified it as well and got 1/3. If you got either of those right, give yourself a little pat on the back. And the last one, 1 whole minus 7/10 would equal 3/10. If you got that one, give somebody near you a high five. Nice job, mathematicians. Let's get ready, clear our whiteboards, and we'll get ready for our activity today. You'll need your problem set questions, and you'll want to have a highlighter as well as a pencil to work on each of the problems. We are going to work on the first problem of the problem set together. As we solve these problems, we're going to use the RDW process to help us solve each of the word problems involving the addition of fractions. Remember, there might be more than one way to solve these problems too. So in the first one, we'll look at 2 solutions to get to the same answer. Let's get into it. Let's read the first problem together once, just straight through. Read it with me. Sue ran 9/10 a mile on Monday and 7/10 miles on Tuesday. How many miles did Sue run in 2 days? We're given a good amount of information about Sue and how much she is running. Let's grab our highlighters and highlight some important information. We know that on Monday, Sue ran 9/10 of a mile. And then on Tuesday, we were also told that Sue ran 7/10 of a mile. Our job is to figure out how many miles did Sue run in that 2 days. So in total, we have to figure out how many miles did Sue run. Let's draw a picture using this information. So we want to figure out in the 2 days that Sue ran. We know on Monday she ran 9/10. Let's put that in our first box. We know on Tuesday she ran 7/10 of a mile. However, we don't know how much she ran in total for both of those days. Let's use the information in our problem to solve. Remember, we're going to do 2 solutions for this one. So let's write solution 1 here, and we're going to solve underneath solution 1. We're given information, and we know we need to combine these 2 numbers to find out the total. So we need to add these 2 together. Let's do 9/10 plus 7/10. If we were going to add that together, we just practice adding fractions. Our denominator is the same, so we keep it the same. We add the numerators. 9 plus 7, write it on your papers, is 16. If I look at 16, I can tell that the numerator is bigger than the denominator, or that we have an improper fraction here. We need to take our improper fraction and break it down a little bit. We have 1 whole in this. I could pull out 10 out of 10, 10/10, right? That fraction. And we would still have 6/10 left over. If we were going to write that as a mixed number, 10/10 is 1 whole, and 6/10 is going to be our fraction that goes with it. Now, that's not the only way we can solve this problem. Let's look at another way we can solve it. On your papers, take the time now to write solution 2 and write the same addition problem, 9/10 plus 7/10. We're still going to use that same information, but we're going to solve it a little bit differently this time. If you need more time to write the equation down, pause the video now. For this solution, I'm looking at 9/10, and I'm thinking that's pretty close to a whole already. Let's break 7/10 down so we can get that 9/10 to 10/10. Let's pull out 1/10, and then we'll break it down 1/10 and 6/10. So we're just breaking 7/6 down into two fractions. If we do that, and if I look at 9/10, 9/10 plus 1/10 equals 10/10. So we can write that in our equation here, but we still need to use this 6/10. So we have to add that in as well. If we were going to add these two together, 6/10 and 10/10, well, 10/10 is a whole, and 6/10 could be our fraction again. Now, some of you may have noticed that 6/10 is a fraction that we can also simplify. So if you wanted to simplify, or notice we could simplify this, 6/10, 1 and 6/10 is also equal to 1 and 3/5. So we got the same solutions here. We just broke our problem down in two different ways. Here, we just added our numbers and simplified when we got an improper fraction. And in our second solution, we noticed that we were close to a whole. So we just pulled out what we needed to create the whole and take a leftover fraction that we could have added onto our mixed number. Now that we have the answer, we want to write our total in a sentence that answers the question that we were given originally. We were asked about how many miles did Sue run in 2 days. So we can say Sue ran 1 and 6/10 miles. And we'll circle that because that's our answer. Nice job, mathematicians. You guys are going to continue to work through these different problems. Make sure you use strip diagrams to help you model the equations. And then when you're done, you want to not only have your work shown, but you want to write your total or your answer to that question that you're being asked and circle it so that we're able to see what your final thoughts are. You guys are going to continue and you're going to work a little bit more together on Mr. Salazar's son's birthday cake. I know I like some cake. Go ahead and help him out to figure out how many pieces of the cake are left over after they get some nibbling on it. I'll see you soon, mathematicians. Bye.